Hello everybody. Today's video is going to be a more technical related video about smart contracts on Antelope based blockchains like EOS and WAX. If that's not your thing, feel free to just tune out and come back next time. But today I'm going to be talking about something that I just came across in a Telegram channel, which was somebody asking about how to migrate table data in a WAX or EOS smart contract. They have a table on their contract. They want to modify the table, but there's data in the table. And that's a bit of a tricky situation when it comes to these smart contracts, because if any of you have ever built a database on Web 2 before, like MySQL, for example, you know that if you build something, you have this whole database and a table in there, and there's a whole bunch of columns in that table. Maybe at some point you realize, oh, I got a new idea. I want to add another column to this table. Well, in Web 2, that's easy. You just add another column. It's no problem. It builds on the existing table and you're basically done. It's fine. But in these smart contracts, that's not the case. If you try to modify the structure of your table by, for example, renaming something or adding another column, you basically break everything. The only way that you can do that is if you erase all the data from the table before you change the table structure. So I'm going to go over an example today and walk you through the process of how I go about this. It might not be the only way, but this is what I do and it works perfectly fine. So I have this table here on a smart contract on the Wax testnet. It's called dummy. It's just a dummy table full of dummy data. And I filled it up with 2,000 rows full of data here. Just dummy data, just the name dummy and a fake balance. And that's it, 2,000 rows. And if we take a look at this table here and how it's designed, you can see that I have my dummy table and there's 3 different fields in it. There's an ID, a name, and a balance. Now let's say I've decided, this contract's been running for a while. I have these 2,000 rows in here. There's 2,000 different people using my contract. And this is live. But all of a sudden I've realized, you know what? It would be great if I could add like another field here to store some NFTs. So I put a vector of uint64ts here. I name it asset IDs, right? But this would break my table if I did this while the data was already in there. So I basically have 2 options here. The first option is to just migrate this all to a new table with a new name. I could call it like, dummy new or dummy 2 or something like that. And that's fine. That would work fine. Or the other option is to migrate it to a new table called dummy new or dummy 2, just like I said. But then after I'm done with that, I erase all the existing data from the first table, and then I migrate everything back to the first table after I restructure it. And that allows me to keep the table name, because to some people that might be important, right? You might have some APIs out there, or some other people might have built applications based around your contract, and it might all be dependent on a table having a specific name. So it might be important to you to keep the table name. If that's the case, you're going to want to migrate over and migrate back. So I'm going to show you how I do that right now. So this I can't do. I can't just change the structure yet. I have to get rid of this. I have to keep it the same. And what I'm going to do is I'm going to start off by creating a second table. And I'll just call it dummy copy. And I'm going to keep it exactly the same as the first table. I don't need to change anything because I'm just copying over the existing data. So let me go and define this in my header file, go down to where I have my tables defined, and I'll say dummy copy, and I'll call it dummy copy T. Okay, so now I have that defined. So the first thing I'm going to do is create an action that allows me to take records from the first table and migrate them over to the other table. I should point out before I do this, by the way, if you have like a live table where users have like money in your contract, or the data is very important that it doesn't get changed in this process, you might want to pause your contract completely while you're doing this. It's actually a good idea to do that. So like, for example, if you had an action on your contract called stake and people would use it to stake stuff, you might want to just go right into that action and just put check false right at the top of it and throw an error and just prevent people from doing anything that's going to change any data, because you want your stuff to persist perfectly. You don't want anything to get changed. So make sure you pause your contract while you're doing this if other people are able to interact with it. But okay, I'm going to create this action. I'll call it copy dummy. I'll pass it a couple arguments, a name, which will be the user, and that's just going to be me. I'm just going to require my authorization and make sure it's me that's signing this. And then I'm also going to enter a quantity here. And the reason that I'm doing this is because you run into chain CPU limits depending on how much data you have in your table. So like I said, I put 2,000 rows in here. There's actually a possibility that I would have no problem migrating these whole 2,000 rows, but it's also possible that I would run into an error that this transaction, iterating through all these rows and moving them over to a new table, it might be so large that it does not fit within the chain limits of 30 milliseconds. So I might need to break this up into smaller transactions. So what I would do here is I would say, first of all, require auth user, and then if the user is not equal to me, throw an error. Only Mike can do this. All right, so now we know nobody else can call this action. I'm going to define a count and set it to 0, and then I'll say while count is less than quantity of rows, and after I'm done with the logic, I would increment the quantity of rows. I would increment the count, and I'm going to perform my logic in here, which is going to be migrating over the table data. So I'll say iterator is dummy t.begin, dummy t copy dot in place. I'll set the contract to the RAM pair. And that's another thing I should mention here. Okay, let's say that you have users paying for their own data. People stake to your contract or something like that. Everybody pays their own RAM. You cannot increase the RAM usage of a user without their permission, without them signing a transaction. So if you're doing anything that's going to increase the amount of data in these rows, you have to take over as the RAM payer for now. You cannot keep the user as the payer if you're adding more data. For this specific copy that I'm doing right now, this actually wouldn't be a problem because I'm literally migrating over an exact copy. But when I migrate back, I might be adding something new, which would increase the cost of the RAM, and then I have to take over as the payer. So just make sure you're aware of that. You're going to be paying a lot of RAM if you have a ton of records in your contract that other people are paying for at the moment. Okay, so dummy t copy dot in place, and there's 3 fields in here. So I'm going to do copy.id equals it ID, the same ID as in the first table. Copy dot, I forget what I even have in this table, name and a balance equals it name. Copy dot balance equals it balance. Then I'm going to do it equals dummy t dot erase it. So this is going to erase the existing row. You may want to go about this a different way. Maybe you don't want to erase it right away, but this is also going to depend on how you have things indexed in your original table. Because look, we're doing this quantity of rows thing right here, right? So in this particular table, my primary key is this numeric ID right here, which in this particular case, it's just so perfect. It happens to start at 0 and it increments itself up one by one to the last row, which is 1999. This would be a best case scenario. This is perfect. In this case, I actually don't have to do this erase right here if I didn't want to, if I want to be safe and like make sure everything was going to work perfectly before I go and erase stuff. Because based on the way it's indexed, I could add another parameter to this action here, and I could say skip amount. And on the first transaction, I would set the skip amount to 0, and maybe I do like 500 rows. And then on the second transaction, I would just say skip 500. Right? That would be perfect. There would be no problem because I'm able to identify the row by primary key, which happens to be the amount of rows that I'm doing. It's a perfect scenario, but in most scenarios, that's not going to be the case. A lot of times, your table might have a primary key of, for instance, it might just be the name, and then your primary key would return name.value. In this case, it would be so unpredictable what the primary keys of the rows are going to be that there would be no way for you to just skip 500 and jump to the correct row. You would have to iterate through every row, which defeats the whole purpose of skipping in the first place because it will still eat up that amount of CPU and you'll reach transaction size limits. So by erasing every row as you place it into the new table, you're always going to have that iterator pointing to the beginning row of the table, and it's not going to have you run into those transaction limit issues, if that makes sense. But okay, so this looks good. So this would copy everything over to the copy table. it would erase everything from the first table. I'm going to make sure I go and define this in my header file, and then I'm going to compile it real quick and push this to the blockchain because this is actually all we want to do for now. I made a typo. This should not be dummy t copy. This should be dummy copy t. Okay, I actually just pushed this to the blockchain, but before I do anything, I realized I made a mistake already. So we're not accounting for something here. While we're doing this while loop right here, we might already have completed all the rows in the table. So we have to make sure that we're not at the end of the table also. Before we say that, we'll just say if dummy t dot begin equals dummy t dot end return, and then we're done. So I'm going to recompile that again and deploy it back to the blockchain. All right, so if I refresh this page now, we should see another table called dummy copy. And there it is. There is currently 0 data in it. There's no rows. But now if I do this copy dummy action, I enter my username. I don't know why I didn't just require auth MikeDCrypto5. There was no point in adding the user as a parameter or argument. But let's say we're going to do 500 rows. Remember, we started with 2,000. So once we do this, there should be 1,500 rows left in the table, in the first table, and 500 in the second table. Okay, transaction is signed. And if we go back to tables, look, inside of the original dummy table, the first row is 500. So that's already a great sign. And if we go down, last row is 1999. So 500 were removed, and are they in the new table? That's the question. And they are. 0 through 499 are in the table. So let's try and do this with 1,500 rows and see if it works. And that seems to have worked fine. So in this particular case, we actually didn't even need to add this quantity of rows thing. But some of you out there might have millions of rows in a table. So you're going to have to break it up into multiple transactions. But yeah, if we go back to the table, the first one is completely empty now. And the dummy copy table has 1,999 rows. So they're all in there. At this point, since the first table is empty, now we can modify it without breaking anything. So now that the table is empty, now we can add another column to it. So let's just say, instead of asset IDs, let's just say it's like a timestamp we want to add into here. So let's just say uint64t, and we'll call it like, last claim or something like that. So now let's go back to our action here. And, we really could modify this current action that's right here. But just to be safe, I always get weird about this. I worry about forgetting to switch things back and making a mistake. So I'd rather just make a whole new action myself, just out of personal preference, because I'm weird like that. But you could just modify this existing one if you wanted. What I'm going to do, I'm just going to say copy back, and then I'll say if dummy copy t dot begin equals dummy copy t dot end return auto it equals dummy copy t dot begin, because remember, we're now copying back from the copy table back to the original, and we're going to be emplacing it to dummy t, not copy t. We'll say dummy dot id equals it dot id. I'm sure you get the point here, and we're going to make sure that we erase dummy copy t iterator, not dummy t. And that's pretty much it. Maybe you have a specific thing that you want to actually put into that new column that you created. So you might want to do like dummy dot last claim equals now. Now is a function that I have on the contract. If you care what's in it, it's basically just current time point, second since epoch. But you don't have to fill this out. If you don't, it'll just set it to whatever the default is, which in this case would be 0 since it's a number. I'm going to recompile this again and deploy it back to the chain. Well, at first I should probably define it in the header file. Okay, I have now deployed it, so we should see a copy back option when we refresh it. And we do. Quantity of rows. Let's just try to do all 2,000 at once and see what happens. Yeah, so this is a problem that you're going to run into sometimes when you make updates to a contract, especially on the testnet. A lot of times Anchor Wallet has not updated their ABIs. They probably refresh this every few minutes, every 5 to 10 minutes, so sometimes you're stuck waiting here. If you're in a rush, you can just write a Node.js script real quick or something. I'm just going to wait a minute, and I'll come back when this is ready. Okay, it's been 87 minutes, so now I can finally sign this. And it seems to have handled all 2,000 rows with no problem, so let's take a look. at the tables. A dummy copy should be empty, and dummy should be filled up with the current time as the timestamp for each user. So let's take a look. And it's looking good. All 2,000 rows are in the table. All of them have the correct timestamp. And we didn't break anything, most importantly. If you just tried to change that and add that extra column without migrating the data, erasing all the data from the first table and then migrating it back, you would have broken stuff. You would have gone here on the Block Explorer and not seen anything. So keep that in mind. One other thing I should mention is that in the case where you do make a mistake like that, if you update the structure and you break stuff and you don't see anything, luckily, if you change everything back to how it was in the first place, it will actually make the data reappear again. I actually had somebody do that recently. They replaced their token contract, which had everybody's balances, the token information, all that stuff. They replaced it with a completely different contract, and everybody's balances basically disappeared. But we redeployed their token contract back onto their account, and everything went back to normal. So there is an option, but be very careful. That's pretty much it as far as this tutorial goes. If you have any questions, if I left anything out or whatever, just leave a comment beneath the video. There's also going to be links to my Telegram and Discord down there, and you can reach me in both of those places. Thank you guys for watching. I will see you next time.